Swayam Prabha. Digital India. Educated India.
Welcome to today's lecture. So, at the end of today's lecture, we will go beyond learning about the characteristics, architecture and protocols of IoT, and we will learn how to select sensors for use in the industrial Internet of Things. In a further lecture, we will learn about applying a set of design principles to create smart products. So, what are sensors? Well, a sensor is a device that produces an output signal for the purpose of sensing a physical phenomenon. Okay. So, there is some physical phenomenon that is going on, and the sensor helps you create a signal for that phenomenon. Okay. Maybe there is temperature, okay, in the atmosphere, and you want to measure the temperature. So, you use a sensor and it tells you the temperature, and that temperature of course is a measurement. Okay. It is 10 degrees or 15 degrees or 20 degrees. So, we need a signal, an output signal, which tells us what is the measurement. Okay. So, sensor is a device that produces an output signal for the purpose of sensing a physical phenomenon. So, some examples of sensors you can see here, okay, and these sensors have different pins which are usually metallic, from which we are able to gather that data. So, what do sensors do? Well, the sensor attains a physical parameter and converts it into a signal which is suitable for processing. Okay. So, this may be electrical signal, maybe a mechanical one or an optical one. Okay. So, it attains a physical parameter, or it receives a physical parameter as input and converts it into a suitable signal, which can be processed, and such that the characteristics of any device or material can be understood. Okay. So, that if particular physical quantity can be extracted. So, output of the sensor is a signal which is converted to a human readable form, like changes in characteristics, changes in resistance, capacitance, impedance, etc. So, here is a block diagram that tells you how a sensor works in a real system. So, a sensor receives the input from the environment or the system where it is in, okay, and then it goes through a processor, okay, and after having gone through the processor, it goes into an actuator possibly, and from the actuator you may get some output. Okay. So, there are additional things that you may need to understand the sensor's reading. So, that additional thing is known as a transducer. So, a transducer, what it does is it takes the signal from one form and converts it into another form, which is suitable for us. Okay. And you may have a transducer at the sensing stage, or you may also have a transducer at the actuating stage. Actuation is where you are doing something, okay, based on the sensor input. So, these transducers, what do? Well, they convert a signal from one physical structure to another, or one type of energy to another type. So, transducers may also be used as actuators in various systems. Okay. So, transducers convert the signal from one physical structure to another, or from one type of energy to another type. So, if we look at the operation of the transducer, you can lay it out as this. So, the sensing element gets some input, then there is a transduction element, and that gives you a output that is readable or interpretable. So, let us look at how sensors can be classified. Typically, sensors can be classified as one of three types. One is passive and active. Yes. So, it is usually a hardware. Okay. So, we will look at types of transducers. Okay. So, you can also classify sensors as analog and discrete, and you can also classify them as scalar and vector. So, let us look at what these mean. So, firstly passive sensors. So, passive sensors, as the word passive suggests, they are passive, they are not active. Okay. So, they cannot independently sense the input. Okay. They need some action to be taking place to be able to sense the input. So, for example, accelerometer, soil moisture, water level sensor or temperature sensors. So, these are passive sensors. Then there are active sensors, they can independently sense the input. Okay. So, examples of those are radar. Okay. Radar stands for radio detection and ranging, sounders or laser altimeter sensors. Okay. So, they are themselves doing something to sense what is there in the environment. Okay. So, radar is sending out some waves, laser altimeter sensors, they are sending out some laser rays, and likewise sounder is sending out some sound waves. Okay. So, these need to do something themselves to be able to sense the input, they are active. Okay. And passives, they do not need to do something. Okay. You can also classify them as analog and discrete. Okay. So, analog sensors measure continuous signals, and discrete sensors, they measure signals at discrete intervals of time. Again, discrete sensors can be of two types, binary and digital. So, binary will sense at two levels, maybe 0 and 1 or 0 and 5. Okay. So, two levels, and digital will be a digital measurement. So, that can be a real number. Okay. So, discrete sensors have two types, binary and digital. So, if you look at truck like this, where are all the sensors? So, the sensors are located all over. So, there are HVAC sensors here. Okay. There is a combo sensor for steering, measuring the torque, okay, during steering. There is a throttle position sensor here. There is a transmission sensor here. There is a headlight range sensor here, a brake position sensor near the wheels. Okay. There is a mirror sensor by the mirror. There is an accelerator pedal angle sensor here, where the driver sits and is placing his foot on the pedal. Okay. There is a passive wheel speed sensor here. There is a brake wheel sensor here. There is a chassis level sensor here. There is a steering angle sensor right here. So, all of these sensors are located all over the truck. So, you can see in a complex product like a truck, you have loads of sensors and they are making lots of measurements. So, third classification of sensors is into scalar and vector. So, scalar sensors, they detect the input parameter only based on the magnitude. Okay. So, they do not need to detect the direction, only the magnitude is important, as the name scalar suggests. So, the answer for the sensor's output is a function of magnitude of some input parameter, and that is not affected by the direction of the input parameters. So, the direction of the input parameter does not matter. So, for instance, temperature sensors, does temperature have a direction? No. So, that is a scalar sensor. Gas sensor, so that will tell you whether there is a specific gas or not, carbon monoxide sensor, carbon dioxide sensor, oxygen sensor. Okay. So, those are scalar sensors. Strain again does not have a direction. Okay. Color sensors, smoke sensors. Okay. So, these do not need to sense the direction. Then there are vector sensors. So, in vector sensors, the response of the sensor depends on the magnitude of the direction and orientation of the input parameter. Which direction is the input in? So, acceleration has a direction, right? So, accelerometers are vector sensors. Likewise, gyroscopes, they are vector sensors. Magnetic field, again that has a direction. So, that is a vector sensor. Then motion detector sensors, those are also direction sensors. So, where are sensors used in the industry? So, if you consider the aircraft industry, the typical sensors, well, there are hundreds and thousands of types of sensors that are used in the aircraft industry, but some of the common ones are displacement, speed, acceleration, elevation, how high is your aircraft above the ground, heading, okay, which direction is the aircraft going in, north, south, east, west, northwest, northeast. Okay, so that is important, which direction your aircraft is going in. What is the pressure? Pressure inside the aircraft, pressure outside. Okay, what is the temperature in which the aircraft is passing by? Okay, and what is the temperature inside? Fluid flow. Okay, that's important because the aircraft is going through turbulence sometimes, so you need to measure the fluid flow around it. And there are lots of different motors, so voltage, current, and also GPS to find out where exactly the aircraft is located. In the automobile sector, you have displacement centers, speed, force, pressure, again temperature, fluid flow, fluid levels, vision, voltage, current, GPS, radar, sonar. So, all of these variety of sensors are used in the automobile sector, similar to the aircraft. But of course, the difference between these two is that you do not need an elevation sensor for typical automobiles. For home heating systems, you need to find out the temperature, the pressure, and the fluid flow. For milling machines, which you may have used in your first year in your workshop technologies, typical measurements are displacement, speed, force, acoustics, okay, how much noise is the milling machine making, okay, temperature, voltage, current. In a robot, you may have some vision systems, so optical image, displacements, speeds, forces, torques, tactile measurements, lasers, ultrasounds, voltage, current. So, these sorts of sensors are there in robots. In a wooden drying kiln, the typical sensors are temperature, relative humidity, moisture content, airflow, etc. So, this is sort of introducing you to different types of sensors that are required in different industrial systems. Now, we are talking about transducers. Okay. So, some examples of transducers, and you are asking whether these are physical devices or not. They are. Okay. So, RTD, this is a thermocouple. Everyone knows the thermocouple? Yeah, must have studied in your physics, college physics. Two different metals to be able to measure a temperature. Okay. Potentiometer, piezoelectric crystals, strain gauges, LVDTs. Okay. So, these are all transducers. So, let us talk about some of the types of transducers. So, thermistor is a common type of transducer. So, here the temperature change is converted into output resistance. Okay. In a potentiometer, the displacement is converted into a output resistance. In a thermocouple, the temperature is measured by detecting the thermo-electromotive force between two dissimilar metal junctions. In an I to P converter, you convert a current signal, which is typically of the order of 4 to 20 milliamperes, into a proportional pressure signal, which may be of the order of 3 to 15 psi. Okay. Other transducers, P to I converter converts pressure signal into proportional current output. Piezoelectric crystals, they use the property of certain materials to generate an electric charge in response to applied mechanical stress and vice versa. Okay, so, they use the property of certain materials to generate an electric charge in response to some pressure or stress that you have applied to it. So, pressure is converted into some electric charge. So, that is a piezoelectric crystal. Strain gauges, they convert force, pressure, tension, weight, etc., into a change in electrical resistance. Okay. LVDT, again that converts a change in small displacement into electrical output. RTD, that converts a temperature change into a output resistance. Okay. Everyone understands the types of transducers. Then we come to actuators. Okay. So, sensors done, transducers done, then the next bit is actuation, where you do something in response to the signal that you have got. They may be, yes. So, actuators again can be classified based on the type of motion or the type of medium in which they are operating. So, two different types of actuators based on the type of motion are linear and rotary. Okay. So, whether they are providing linear motion or whether they are providing rotary motion. Based on a type of medium, again you may have actuators such as hydraulic, So, that operates in a fluid, okay, usually water like fluid, or pneumatic. So, using air, okay, and actuation using electrical signal. So, that for instance, a motor. So, that would be electrical actuators. Then you may also have manual actuators. Some examples of actuators here. So, this is a stepper motor, this is a DC motor, this is a hydraulic pump, this is a pneumatic cylinder, this here is a solenoid valve, and this here is a relay. Okay, so, these are different types of actuators. Again, if we look at what are the different types of actuators in different industries. So, for aircrafts, you may have DC motors, stepper motors, relays, valve actuators, pumps, heat sources, and jet engines. In automobiles, you may have again DC motors, stepper motors, valve actuators, linear actuators, pumps, and heat sources. Home heating systems, you will need some motors, some pumps, and heat sources. In a milling machine, there are usually motors which may be DC or AC. In a robot, you will have again different types of motors, some hydraulic actuators, some pneumatic actuators. In wood drying kilns, you will have some motors, pumps, and heat sources. Does everyone understand the difference between sensors, actuators, transducers? Yeah. So, let us look at some of the characteristics of sensors. So, again sensor characteristics can be broken down into static and dynamic. So, first let us look at the static characteristics. The first static characteristic is accuracy. Accuracy is the capability of measuring instruments to give a result close to the true value of the measured quantity. Okay, so, how accurate is my sensor? That means, how close is my result to the true value that I am measuring. So, let us say the temperature is 25 degrees and my measurement is 24.9. So, what is the accuracy? 0.1. Okay. So, accuracy is all about measuring errors, okay, and this is measured by absolute and relative errors. So, you may either find out an absolute error, okay, or a relative error. So, how do you find out absolute error? Well, absolute error is the measured value minus the true value. So, whatever you have measured minus the actual value. Okay, so, in the example I was citing, 24.9 minus 25. So, that would be minus 0.1 degrees Celsius. The relative error is the measured value divided by the true value. So, 24.9 divided by 25. So, that would give you relative error. The next characteristic of a sensor is that of the range. Okay. As the name suggests, it is the highest and the lowest value that it can measure. So, let us say there is a RTD device and that is measuring in the range of minus 200 degrees to 800 degrees. So, that is a range, okay, the lowest value to the highest value. So, beyond these values there is no sense or there is no response for the sensor. So, that is the characteristic of the sensor, that is it can measure in this range. Okay. Beyond that it may not be able to measure or it may even get damaged. Okay. So, when you are looking up a sensor for use in a project, then you need to look at the range and you need to look at the accuracy. What is the precision with which I want to measure my physical value and what is the range in which I am operating. Okay. So, if you get these wrong, then the sensor will not do the job for you. The next characteristic is that of the resolution. So, it is an important specification for the selection of sensors. The higher the resolution, the better the precision. Okay. So, for instance, can I measure to 0.1 of a degree or can I measure to 0.01 of a degree? Can I say the temperature is 24.89 degrees? Okay. So, that is the resolution. Okay. So, it provides the smallest changes in the input that the sensor is able to sense. The smallest change, is it 0.01, it is 0.001, 0.0001. So, that is what is the resolution. Then you have the precision, which is the capacity of a measuring instrument to give the same reading when repetitively measuring the same quantity. Okay. So, you measure a temperature 5 times, okay, under the same prescribed conditions. Okay. So, is it going to repeat that same reading? So, it implies agreement between the successive readings not closeness to the true value. So, maybe the temperature is 25 and you are measuring 24, but does it give 24 on 5 different readings? So, that is your precision. So, it is dependent on the variance of a set of measurements. So, that is a necessary, but not a sufficient condition for accuracy. So, precision is a necessary condition, okay, but it is not a sufficient condition that. So, if the measurements are repeating, okay, so that means, so it is giving the same measurement, but that does not mean it is accurate. So, the temperature may be 25, but if it is giving 24 5 times in a row, that means it is precise, it gives the same reading, but it may not be accurate, it is 1 degree off. Okay. So, there might be another sensor which might give you 24.9, then 25.1, then 24.8, then 25.1. So, that is more accurate, but it is not as precise, because there the readings are changing every time, and that is why you may need to calibrate a sensor. Okay. So, the one that is showing 24 5 times in a row, if you calibrate it so that it gives you a measurement of 25 when the actual temperature is 25. So, that sensor, so once you calibrate it, then it becomes accurate. Does that make sense? The next characteristic is that of sensitivity. So, sensitivity indicates the ratio of incremental change in the response of the system with respect to the incremental change in the input parameters. Okay. So, if the temperature of this room goes up by 5 degrees, okay, then how sensitive is my sensor? Okay. So, maybe the sensor reading goes up by 4.8 degrees. So, ratio of that change to the actual change 4.8 by 5. So, that is your sensitivity of your sensor. How sensitive it is the sensor to the changes in the value that you are measuring. So, that can be found from the slope of the output characteristics curve of the sensor. So, you can draw a graph, as the reading is changing, what is the reading that you are getting, and when you draw that graph, then you can find out what is the sensitivity. All you have to find out is the slope. Okay. So, the sensitivity is the small amount of difference in quantity that will change the instrument's reading. So, the smallest amount of difference in a quantity that will change the instrument's reading. Okay. So, if the temperature goes up from 25 to 26 degrees, does the reading go up from whatever it is by 1 degrees. Okay. So, what is the smallest difference in quantity that will change the instrument's reading? Can it measure 1 degree change? Can it measure 0.5 degrees change? Can it measure 0.1 degrees change? Okay. So, when you are selecting your sensor, then you have to think about the sensitivity as well. Okay. Is my sensor going to be sensitive enough for the type of physical measurement that I am going to do? The next characteristic is that of linearity. So, this is the deviation of the sensor value curve from a particularly straight line. Okay. How linear is the characteristic of the sensor? Its output as the input changes. Okay. So, linearity is determined by the calibration curve. So, you need to create this calibration curve as Stangomer. Okay. The static calibration curve plots of the output amplitude versus the input amplitude under static conditions, that tells you the linearity of the system. Okay. So, when you plot the output amplitude against the input amplitude and you get this curve, that calibration curve will tell you about the linearity of the sensor. So, it is the resemblance to a straight line of the slope of the curve that describes how linear this sensor is. The next characteristic that is often important is that of drift. So, drift is the difference in the measurement of the sensor from a specific reading when kept at that value for a long period of time. Okay. So, let us say there is a ice bath and you keep a temperature sensor in it, okay, and you are able to maintain the temperature inside at 0 degrees, okay, and then you take the measurements from the sensor and you observe it for a long period of time and you see whether it is showing 0 degrees continuously for how long, maybe 1 hour, maybe 2 hours, maybe 3 hours, okay, and then it may start drifting and if you notice a drift in the reading when the magnitude of the measurement is the same, the specific reading is the same, that difference is the drift. Okay. So, let us say it goes up to 0.1 degrees when the temperature of the ice path is still 0. So, drift becomes 0.1. So, take that measurement for a long period of time and then the difference in the measurement from the reading, that is your drift. Make sense to everyone? Yeah. And then the next sensor characteristic that is often important is repeatability. So, this is a deviation between measurements in a sequence under the same conditions. Okay. So, conditions are the same and then you take discrete measurements, okay, and the deviation between these measurements, that tells you the repeatability. So, measurements have to be made under a short enough time duration, so that there is no significant long term drift. So, repeatability is different from drift in the sense that repeatability is all about making these measurements one after the other quickly, and then you want to see whether the measurement repeats or not. So, some of these terms have slightly overlapping meanings. So, do not be confused by that, okay. But it is useful to think about these terms and see if it makes sense in your mind, okay. And often when you go to a job interview, etc., you may be asked to tell the difference between accuracy and, let us say, precision and repeatability and drift. So, if you are able to talk about them, so that shows that you understand these characteristics. Okay. So, everyone understands the static characteristics. So, now let us look at some dynamic characteristics. Sure. Repeatability is whether the measurements which are taken. So, the question that you asked is what is repeatability? So, repeatability is whether the measurements which are taken close enough, how close are those measurements to each other. Okay. Let us say I am measuring 25 degrees temperature in a room, my sensor readings are 25, 25.1, 25, 25.1. So, that those 4 readings which I took to measure the same temperature, whether they repeated or not, that is repeatability. Okay. So, the deviation between these measurements, okay, so that gives you the repeatability. So, deviation in this case, let us say, was 0.1. So, then the repeatability is 0.1. Okay. But these are not measurements taken after long term. So, they have to be done quickly one after the other. So, that is the difference between repeatability and drift. Okay. So, if we look at the characteristics of sensors, again we may see that they are a 0 order system or a first order system or a second order system. So, these are 3 typical types of dynamic characteristics that you may see. So, as the time changes, what is the plot that you get of the sensor reading. So, 0 order system, the output shows a response to the input signal with no delay. Okay. So, immediately you get the response to your signal. So, typically it does not include any energy storing elements. So, energy is not getting stored anywhere. So, immediately you are getting the sensor output. So, examples are potentiometers, linear and rotary displacement sensors. Okay. So, those are typically 0 order systems. In first order systems, the output approaches the final value gradually. So, typically this consists of an energy storage and a dissipation element. In second order systems, the output is usually complex. Okay. The output response of the sensor oscillates before steady state. Okay. So, if we think about the output characteristics, for a 0 order system you will get instantaneous. So, let us say this is my 1, okay, and I have given a step input. So, this is my input and my output is also the same. Okay. For first order system you will get a characteristic like this. For second order system you will get it something like this. Make sense? So, those of you who have learned control systems will know about these characteristics, but for the purposes of our course it is useful to know what is a 0 order system, first order system and second order system. Make sense to everyone? So, you can actually use Laplace transforms to define these outputs. So, typically the Laplace transform, so output over input. So, let us say the output is O of s and the input is s. For the first order system, the transfer function will be of the type or some constant. Okay. And for the second order system, you will get this to be okay. So, this will be the transfer function for a first order system and this will be the transfer function for a second order system. How many of you have done a course on Laplace transforms? 1, 2, 3. I am surprised because Laplace transforms was a compulsory course when I was doing my BTech. So, okay. Everyone understands what this is? Actually, let me explain this a bit more. So, what I mean is, if there is a system like this, okay. So, let us say I call my system G and there is an input I and it is giving an output O. Okay. So, this I is varying with time, okay, and this O is varying with the time. Okay. So, the Laplace transform is simply this, say I of t e to a minus s t dt. Okay. So, 0 to infinity. Okay. So, that gives you I of s. So, that is a transform. So, you are going from the time domain to another domain, the s domain, and you are taking that. Okay. So, that goes in here, this transform of this goes in here. So, this is your transfer function of this sensor. So, we are going from the time domain to the s domain to describe how this system behaves. Okay. And then with time you can plot your graph. Okay. Everyone understands? Okay. So, then we come to controllers. Okay. So, we have sensors and actuators, but to in any physical system you want to control the physical variables. So, typically to do that you need controllers. Okay. So, what you have got, what you will get today in the IoT kit will include an ESP8266 microcontroller. Okay. So, it has the ability to perform control actions. Okay. So, controllers are of different types. So, they may be digital or continuous time. So, digital controllers again are of different types. So, microcontrollers, okay, DSCs or digital signal processor based controllers, example is here. Microcontroller example is Arduino or your ESP8266 board, ESP32 board which I have shown you previously. So, those are all microcontrollers. Okay. Then there are FPGAs or field programmable gate arrays. There are also CPLDs or complex programmable logic devices. Okay. Then there are programmable logic controllers, these are very common in industry. Okay. And you can, if you go down to your workshop also you will see lots of PLC controllers, they are everywhere actually. So, in the milling machines etc., everywhere you will see this PLC controllers. Then there are industrial computers based on industrial buses. Okay. So, those are also digital controllers. So, they may use different buses as a VME bus, VXI, PXI etc. Okay. So, this is a VXI mainframe computer, the VME embedded computer. So, there are various types of controllers that are available. So, sensors, actuators, transducers and controllers, 4 things that we have learnt. Okay. So, now let us look at the different types of sensors, because you will be using different sensors in your project. So, it is nice to open up your eyes to all the different types of sensors and what they do. So, firstly electrical sensors. So, electrical proximity sensors, they measure the proximity of objects to the sensor. So, those again may be contact or non-contact types. Okay. So, contact types will tell you if the sensor is in contact with a certain object, non-contact types will measure the distance from a distance. So, simple contact sensors, they operate by making the sensor and the component complete an electrical circuit. So, when there is contact between the sensor and the object, the circuit is completed, and once the circuit is completed, then you know that the object is in touch with the sensor. Because the circuit is completed, LED may glow or there might be some electric current flowing. Non-contact proximity sensors, they rely on the electrical principles of either induction, okay, for detecting metals. So, they use induction to detect metals, or they use capacitance for detecting non-metals. So, L or C, everyone recollects electrical circuits, L or your C. Okay. Your induction for detecting metals. So, for metals you need induction, for non-metals you need to use capacitance. So, some examples of electrical sensors. So, light sensors, they are also known as photosensors, and they are an important sensor. So, a typical one is light dependent resistors or LDRs. Okay. So, the property of LDR is that its resistance is inversely proportional to the intensity of the ambient light. That is, when the intensity of light increases, the resistance decreases and vice versa. So, the resistance is inversely proportional to the intensity of the ambient light. If there is too much light in the room, then its resistance decreases. If there is less light, then its resistance increases. So, that is the LDR sensors. Okay. So, I have got a few LDR sensors with me. So, if anybody needs a LDR sensor, do let me know. Okay. So, this is an LDR sensor. I have got a few touch sensors as well. So, touch sensors, they detect something like the touch of a finger or stylus. Okay. So, they are classified into two types, one is resistive, the other is capacitive. So, today almost all modern touch sensors are of capacitive types. Okay. So, capacitive types tend to be more accurate and have a better signal to noise ratio. Touch sensors. Okay. So, I have got a few touch sensors as well. If anybody needs a touch sensor, let me know. Then we have range sensing sensors. Range sensing sensors, they detect how far or near a component is from the sensing position, and they can also be used as proximity sensors. Okay. So, they typically use non-contact analog techniques. You may have short range sensing, which is about a few millimeters, or you may measure a few hundred millimeters using electrical capacitance, inductance or magnetic techniques. So, long range sensing is typically carried out using transmitted energy waves such as radio waves, sound waves and lasers. So, radar, sonar and your laser. So, they measure long range distances. So, radar is typically used in airports. So, underwater sonars can measure up to few kilometers. Okay. Radars also they can go out fairly long, few kilometers. Okay. So, depending on the manufacturer and the application, the distance will vary. Then there are these pneumatic sensors. So, these proximity sensors, they operate by breaking or disturbing the airflow, okay, as the name suggests, pneumatic. So, the pneumatic proximity sensor, that is an example of a contact type sensor. They cannot be used where light components may be blown away, because they will break or disturb the airflow. So, when you are choosing a sensors, also think what is the effect they may have on the system where you are placing them. Will they cause some disturbance? Okay. Optical sensors. So, in the simplest form, optical proximity sensors, they operate by breaking a light beam which falls onto a light sensitive device such as a photocell. So, they are usually non-contact sensors. Okay. So, you must exercise care with the lighting environment when you are using optical sensors. So, example of an optical sensor here. So, optical sensors can be blinded by flashes from arc welding process, airborne dust and smoke clouds. So, they are very sensitive to disturbances in the air, in the environment. So, if you are using optical sensors, make sure that they are not facing this sort of disturbances. Then we have speed sensors. They are used for detecting the speed of any object or vehicle. Okay. So, examples of speed sensors are wind speed sensors, speedometers, UDAR, ground speed radar. Okay. So, this is an example of a speed sensor. Then you have temperature sensors. So, I have got a few of these. Okay. So, these are devices which monitor and track the temperature and give the measurement as an electrical signal. Okay. So, these signals will be in the form of a voltage and they are directly proportional to the temperature measurement. So, depending on temperature measurement you get a voltage and then you convert that into your temperature measurement. So, you get a voltage as the output from the sensor. Okay. And that goes into your microcontroller board and you are processing that to tell what is the temperature of the environment. And we have seen this sensor, okay, the PIR motion detection sensor. So, they are passive infrared sensors. So, it is an electronic sensor that is used for the tracking and measurement of IR light, infrared light that is radiating from objects in the field of view. So, they use pyroelectricity to find out whether there is motion or not. So, mainly detects human motion and movement. So, you saw this in the last class. So, this is what it looks like, and there are 3 terminals usually. One is your VCC, the second is the ground, and this is where the output comes out, whether there is motion or not. You get it from the middle pin. Okay. Then we have these ultrasonic sensors. So, the principle of the ultrasonic sensor is similar to the working principle of sonar or radar, in which the interpretation of echoes from sound or radio waves is used to evaluate the attributes of the target. So, there is a ultrasonic wave that goes out, okay, from these you can call them speakers, okay. And so, there is a trigger signal, then there is a echo signal, okay. This is connected to the input voltage, this is the ground, okay. And so, this is where the output comes out, okay. What is the voltage output, and based on that you can tell what is the exact distance of the object from the sensor. Okay, we have seen this in operation. Yes.
Sir, why in every sensor we have one pair of these, why not a single speaker?
So, it depends on the working principle. So, these are designed so that the waves that go out, so they will generate the appropriate response when reflecting from the object. So, it is in the design of the sensor. So, you can go into a detailed design and understand how it operates. So, in this case, so actually yes, so to be able to transmit the sound waves from this, you use your trigger, okay, and then you get your echo from the object. So, yeah, this is the receiver and this is the transmitter, is it? Okay, so that's ultrasonic sensor. Okay. So, to summarize what we learned today, that sensors are the backbone of IoT systems. Sensors often work in conjunction with transducers. These transducers convert signals from one form to another. Okay. And sensors may again be classified in various ways. We looked at analog and discrete, we looked at scalar and vector, we looked at passive and active. And then sensors, they sense various variables, force, light, temperature, humidity, motion, etc. And then you use controllers together with the sensors to control the physical systems. What we do next is get into our kit. So, let me explain what is there. So, let us see what is in this kit. So, this is your kit, your name is neatly written on the top, okay. The components that are in it, those are also listed. And in this kit we have ESP8266 board, okay, one ESP8266 board. Then there is a breadboard, okay, there is a breadboard inside it. You got a USB to micro USB cable, okay. Then there are 2 resistors to do your first experiment. Don't worry, there are plenty more resistors if you need. There are 3 cables. So, one is male, you can see a pin coming out here and there is nothing in here. So, male to female connector. This is a male to male connector, 2 pins at both ends. Then there is this female to female connector. Okay. So, very basic and elementary, and there are LEDs of 3 different colors. Okay. So, this is a blue LED, you can see this is a blue LED, this is red LED, okay, and this is yellow LED. Okay. So, 3 LEDs. So, you can create your web server, your on off web server, which you can control from your phone. So, I will post the code for it in the resources section. So, you can take the code straight away and you can work on it. In today's practical session, you will learn how to build an ESP8266 web server. So, all of you have received the ESP8266 microcontroller board, and you have received a kit with a lot of components. So, these components include some LEDs, some resistors, some connecting wires, and also the USB to micro USB connecting cable. So, with those components we will build our first Internet of Things project. Okay. So, to be able to do this practical, the first step is to download and install the Arduino IDE on your computer. Okay. So, download and install the Arduino IDE on your computer. This is a software that comes free of cost, and once you have downloaded and installed Arduino, you will get an interface that looks like this. So, here you can see an interface, yeah, and this is the code for the web server that we will run today. Okay. So, you can see the Arduino interface. I have got the version 2.2.1 with me. There are some menu items on the top. So, those are important, including preferences. Okay. So, we will come shortly to how we will use this interface to be able to do our project. Okay. So, once you have downloaded and installed the Arduino IDE on your computer, the next step is to download and install virtual COM port drivers. Okay. So, some drivers that will enable the connection between your laptop and the board. Okay. So, to get these drivers, what you have to do is you have to go to the web locations which I have specified. Okay. So, these web locations, you can see here, this is one of the web locations, and here you have got the drivers. Okay. So, you have got the drivers that will enable the connection between your laptop and the board. Okay. Your laptop has potentially USB ports, okay, and your board has got micro USB port. Okay. So, you have to connect it, and for enabling the communication between a laptop and that board, you need some drivers that will drive the board. Okay. So, those drivers are available here. So, you can see here they are available in exe format, they are available as a zip file. Okay. So, you can download one of these two and then you can run it. Okay. And once you run it, you will get the driver installed. Now, in addition to the driver that we need today, I have also given a link for another type of driver. So, that is required when you use ESP32 boards. Okay. So, maybe further down the line you might need some other boards to implement your project. So, then this link will be useful, but also you can install it today. So, anytime you connect those sorts of boards to your laptop as well, it will immediately enable the communication. Okay. So, once you have downloaded and installed it, okay, then you will get a message. So, during the installation process you will get windows like this, and you have to click on install, and once you have installed it, then immediately in your Arduino IDE, if you go here and if you look at port, okay. So, if you look at port, there will be new ports which will appear. Okay. So, for instance, in my case it is the COM3 port that is enabling the communication. Okay. So, those ports will appear, and that will indicate that there is communication between your laptop and the board. Okay. The next step is to, so now you have enabled the drivers to communicate between your laptop and the board, but the boards are still not installed. So, you need to install the board for the Arduino IDE. Okay. So, to do that you need to go to File and then Preferences within the Arduino IDE. From the menu item, go to File and Preferences. So, the way you will do it is you will go here, you will go to File and you will go to Preferences. Okay. So, here you can see there is a place for additional board managers URL. Okay. So, that is where you will have to insert this URL arduino.esp8266.com/table/package_esp8266com_index.json. Okay. So, once you have done that, then these boards will appear when you look at boards manager. Okay. So, if you go here and then look for ESP8266, then you will see this appear. Okay. And then you can click on add and these boards will get installed on to your Arduino IDE. Okay. So, once you have done that, okay, then you need to go to Tools, Boards Manager, and you need to install your ESP8266 board. And then once you have done that, there are many ESP8266 boards that are available in the market. Okay. The one which you will be using is Node CMU 1.0, okay, ESP12V module. So, you go to Tools, Board, and you select this. Okay. So, once you have done that, then you will see it will show on the bottom Node CMU 1.0 ESP12V module on COM3. Right now I have not connected it, but when I connect it, it will say connected. Everyone follows? Then what you need to do is create this circuit. Okay. So, you need to connect two LEDs. Okay. One is anode, the other is cathode, anode, cathode. Okay. And then you need to place these two LEDs on your board, and then you want to connect this to this ground line. Okay. So, this is your ground line on your breadboard. Okay. So, you want to connect a resistor, so in series with this LED. So, this resistor is in series with this LED and it connects to the ground line. Likewise, this resistor is in series with this LED and connects to the ground line. Okay. And then this other end of the LED you will connect to ports D1 and D2. Okay. So, D1 and D2 pins on the board. So, D1 and D2 pins are general purpose input output pin 4 and general purpose input output pin 5, okay, on this board, but they will be labeled as D1 and D2. Okay. So, do not confuse between 2 and 4. So, they will be labeled as D1 and D2, but actually it is pin number 4 on the board and this is pin number 5 on the board. Okay. So, that is important because in your code these pin numbers will have to be entered. So, make these connections and connect the ground of this board to the ground of the breadboard. So, that completes the circuit. Your power is coming in here, okay, and then you have one LED and then the resistor and the ground. Okay. And in parallel you have another LED and another resistor with the ground. Everyone understands the circuit? Okay. So, it is a simple circuit. So, create this circuit and you will find that this board is a bit too wide. So, what is the trick? So, there is a trick here, and this trick is you can, because this board is so wide that it will actually occupy all of the pins. So, what you need to do is, there is a little trick, you just need to place it such that the pins on the left hand side they are hanging out and the pins on the right hand side they are inserted into the board. Everyone follows? Okay. So, the pins are inserted into the board and then I have completed the circuit. You see D1 and D2 are connected to the LEDs, okay, and the resistors are connected to the ground, and the ground is connected to the, so only 3 wires, okay, and you can complete the circuit. We are only using this side of the board, okay. So in future projects, if you have to use, let us say, this side of the board, okay, then you can use male to female connectors, because these are pins, so a female connector will go in, okay. Here, because we are using the breadboard, it will be male to male. So we will use 3 male to male connectors. Everyone follows? So set this circuit up, okay, using the breadboards that I have provided you, and then copy the code provided in the resources section of Hello IITK, okay, to your Arduino IDE. Okay. So what you need to do is start a new sketch. You need to go to your Arduino IDE. You can say file, new sketch, okay, and then once the new sketch opens up, you need to copy paste the code, okay. So where is the code? The code is available here, but you cannot run it straight away. You need to make a change. You need to start the hotspot on your phone, okay. So once you start the hotspot on your phone, you will get a network name, okay. So that network name, if there are spaces, you have to include those spaces in the network name. So be careful with the network name. This is a common mistake the students make. And then the password that you have set for your own network, okay. So just change these 2 lines in that code, and then once you have changed those 2 lines in the code, plug your board to a computer, okay. Make sure that you have selected the right board, okay, which is in our case Node CMU version 1.0 ESP12V, okay, and then select the COM port to which your board is connected. So once you have done that, then click the upload button in the Arduino IDE, and then, so this is the upload button, and then wait a few seconds until you see the message done uploading. So you will see the message done uploading at the bottom. Now you can upload the code and it will work straight away, okay. Do not forget to check if you have the right board and COM port selected, and otherwise you will get an error when you are trying to upload. Open the serial monitor. So you need to open the serial monitor. So you can go here, and there is a serial monitor, you see. So click on that. There is a shortcut for it, Control Shift M. So select that, and this serial monitor will open up, okay. So you will see that there will be an IP address that will be visible to you, okay. So in the serial monitor, an IP address will come alive, okay. You may need to press the reset button and it will output the ESP IP address if you have been late in starting the serial monitor. But if you have started the serial monitor in good time, then the IP address will be straight away available. You do not need to press the reset button. There is a reset button on your board, okay. So and once you get the IP address, then copy that IP address, okay, because you need it to access the web server, and then you can go to your smartphone and or your laptop browser, and you can type in that URL. You can type in that URL and it will open up a page like this, okay. And from this page you can control the two LEDs on and off. So if you take a look at the serial monitor, you can see what is going on in the background. So the ESP board is receiving an HTTP request from the client. In this case, it is your browser. You can also see other information about the HTTP request. So these are known as HTTP header fields, and they define the operating parameters of an HTTP and hypertext transfer protocol transaction. So you will see some text like this, okay. So now let us test the web server. So let us see, okay. So the portal is up, okay. So now I will click on, so you can see actually it has glown, and then if I click on this, the red one will also glow. See, red is glowing now, everyone can see, okay. So both are glowing, okay, and now I will click on this and it is off, and I click on this and it's off. Okay. So I click on this, so it glows, you see, and then the second one glows. Okay. And then I click on this and it switches off, and then I click on this and it switches off. Everyone follows? So that's what we have to realize. So that should be it. So thanks everyone for coming.